Seismometers can detect anything that shakes the ground, from earthquakes to industrial noise to bombs. But how do seismologists tell the difference between, say, an earthquake and a large bomb exploding when both release intense ground-shaking forces? Let's examine two methods that are used. The first will introduce compressive and extensional effects of seismic waves as they are reflected in focal mechanisms, and the second will show actual seismograms. When a bomb detonates, the concussive effect pushes seismic energy in the form of compressional P waves, similar to sound waves, in all directions away from the point source. Let's watch it in map view using springs to show the compressions. When the P waves reach each of the seismometers, they record an up signal because the ground is bumped up as compressional first motions. An earthquake doesn't explode from a point, but by sideways slip on a fault plane. When the fault slips, it both pushes the rock ahead with a compressional force and pulls on the rock behind, resulting in an extensional force. Let's replay it using springs to show these compressions and extensions. The part of the fault moving towards the sensor causes a compressional first motion, and the part of the fault moving away from the sensor causes an extensional first motion, recorded as a down on the seismogram. This process means that seismic stations record both extensional and compressional P waves. If we represent compression with plus signs and extension with minus signs, we see that 2 quadrants are compressive and 2 are extensional. If we darken the compressive quadrants, a distinctive pattern called a focal mechanism arises. This pattern tells us that there was a horizontal strike-slip motion on this fault. A variety of patterns indicate whether the fault was normal, reverse, strike-slip, or a combination. In the case of the bomb, all regions of the pattern have pluses. Thus, it would be black in all quadrants. Distinguishing an earthquake from a bomb also requires a close examination of seismic wave patterns. We can show the difference between them by using pairs of seismograms from earthquakes and nuclear explosions that occur near each other. Because the seismic energy of an explosion pushes outward equally in all directions, the result is strong P waves and weak S waves. In contrast, the rapid sideways motion of an earthquake typically produces weak P waves, and because of that shearing motion, it generates strong S waves and surface waves that are of higher amplitude and slower, thus they show up later. In summary, the two principal methods to discriminate between an explosion and an earthquake are by using their seismograms and by their focal mechanism.